Hello, second graders. I would like to talk to you a little about two powerful forces today. So, in our last video, we talked about the forces of push and pull. And we talked about how in science, when we talk about work being done, we're starting to learn about simple machines, and simple machines make work easier. And we have to think about, what do we mean by work? And so work is a force that is used to move something over a distance. And a force is a push or a pull used to make something move or move differently. So two powerful forces that are at work in the world are friction and gravity. So we're going to read and learn a little bit about these two powerful forces. All right, so a little review for us, like we mentioned. What do we mean by work when we say that simple machines help people do work? So work is done when a force is used to move something over a distance. So when there's some kind of a force, that is a push or a pull. And I think I have that as our next slide here. Yes. So a force is a push or a pull used to make something move or move differently. So I'm going to read a little bit from this book, Forces Make Things Move. So we read a little bit from this book in our last video about forces, and that was kind of more about the forces of pushing and pulling. And this part, it's kind of the end of the story, is about friction and gravity. Actually, I think we start with friction, I think. Yeah, okay. So last time we were in the middle of the story, and it was talking about if you're pushing a toy car across the floor and it hits your big brother, you better run. So sometimes you can see what is pushing or pulling, and sometimes you can't. If you roll your toy car and it hits a wall or the couch, you can see that the wall or the couch stops the car. The wall and the couch produce force. The car hits your big brother, you'd better run. It's going to hit him. Look out. The cat looks worried. Alrighty. So if the car doesn't hit a wall or your big brother or the couch or the cat or anything else, you can see it still stops. What is pushing on the car to make it stop? And that is a force called friction. So when we talk about friction, let's see, it says everything is bumpy. Even things that feel smooth like glass or ice are still a little bit bumpy. So even when I am kind of cold, my basement's kind of cold, when I rub my hands together, I can feel my hands are even kind of bumpy, even though I just put some lotion on. You can't feel the bumps of glass. They're too small, and you can't see them either, but they are still there. Whenever two things rub against each other, the bumps on those things rub against each other. The force of the bumps rubbing against each other is called friction. So if you take your hands, rub them together, that rubbing is friction. Friction makes moving things slow down. When you roll your car, if you're a toy car, you're rolling across the floor, the bumps on the floor push against the bumps on the car's wheels a little bit. This friction is the force that stops the car. So the car is rolling, but as the car is rolling, the carpet or the floor is having little bumps that are rubbing against it and slowing it down. And so here's kind of a little zoom in on the bottom of a skate, an ice skate, and then there's little bumps on the ice. And those bumps on the ice, when they are rubbing against the ice skate, got the cat, that is friction. If you push the car along a shiny wooden hallway, it rolls much farther than if you push it along a thick bedroom rug. The rug is bumpier than the hallway. It creates more friction. It makes the car stop more quickly. Wow, look at mine go. Mine doesn't roll. Oh, look at all the carpet. It's a lot more friction on the carpet, a lot more rubbing on the carpet than on the wood floor. And we have some wood floor upstairs, and sometimes we wear our socks and we slide around on the wood floor because there's not so much friction on the wood floor. Whereas down here in the basement, we have carpeting, and can't really slide on your socks on the carpet. Too much friction. What if you roll your car across very slippery ice? It will go even farther than it does on the shiny wooden floor. The ice is so smooth that the force of friction is very small. But even if the car isn't touching anything, even if you pretend it's an airplane and throw it right through the air, it stops moving. It falls to the ground. Two forces stop it. One is friction. Even air has a small amount of friction. Ooh, so as things go through the air, they're also rubbing on the little molecules and particles in the air. It's a picture of an astronaut. There's the moon. Ooh, it's like the super moon that we had the other day. That was so neat in the sky. In space, there is no air. So in space, there's no air friction. Wow, out in space, so there's no air. There's not even any air, any friction in the air. If you were an astronaut and you threw your toy car into space, no friction would slow it down. Your car would keep going forever, unless it ran into your rocket ship. The second force that stops the car is called gravity. If you drop the car, it falls. Why? Why doesn't it stay up? You haven't thrown it down, you haven't pushed it or pulled it, but it moves, so some other force must be pulling it down. That force is called gravity. Gravity is the force that every object has for every other object. Gravity at work, the cat jumping off the chair, dropping the toy. Now, this is something interesting that I hadn't thought about before, is that each of us has gravity. You have gravity. Your big brother has gravity. If the two of you are standing on opposite sides of the room, you both have a tiny, tiny amount of gravity pulling you toward each other. I did not know this before. You will never feel the force of this gravity. It's much too small. So there's a gravity between all objects on Earth that are very slightly pulling us together. Can you feel my gravity? No. The gravity force between any two objects depends on how much they weigh. Most of the time, gravity is a teeny tiny force. When you hold a carrot in your hand, there's a gravity force between you and the carrot. Crazy, but you'll never feel it. There's a gravity force between your big brother and your cat, but neither of them cares. You can feel the gravity between you and another object only if either you or that other object is really, really huge. Really huge, like the size of the entire Earth, the whole planet. Everyone can feel the Earth's gravity. It's a big force. The Earth's gravity pulls you and everything else on or near the Earth down. It pulls things toward the center of the Earth. Oh, and we know the very center of the Earth, the very centermost layer, the inner core, right? If you dug a deep hole and dropped your big brother into it, don't do that. It's not very just. He'd fall until he hit the bottom. The Earth's gravity would pull him all the way down. The Earth has so much gravity that when we say gravity, we're almost always talking about the Earth's gravity, not the gravity between you and your big brother or the gravity between a carrot and a cat. Gravity is such a part of our everyday lives that you probably don't even think about it. If you spill a glass of milk, you expect it to spill down onto the floor rather than up onto the ceiling. If you let go of your toy car, you expect it to fall to the ground. If you throw your car across the room, don't do that either. You expect it to end up on the floor, not suspended halfway up the living room wall. That would be a little freaky, a little bit strange. So gravity is why apples on trees fall down to the ground instead of staying up in the sky. Gravity makes it hard to throw a baseball all the way to the moon. It's why your parents' cars stay on the ground instead of soaring through the air. It's why rockets to space have such huge engines. The big engines make enough force to be stronger than gravity. There's a rocket. All right. So just a quick note, I found this in another book about who discovered how gravity works. Sir Isaac Newton is famous for his studies of physics. He lived from 1672 to 1727. Oh, wow. That was quite some time ago. So about over, well, when he died, it's about 300 years ago. Okay. So this is just a little information about a very famous scientist named Sir Isaac Newton. It says many scientific discoveries come from simply observing nature. One day, Newton noticed an apple falling from a tree. He called the force that brought the apple from its branch to the ground gravity. So if you're wondering, where do we get that term from, that word, Isaac Newton came up with that. He was just sitting and thinking about some things, just reflecting. And then an apple dropped on his head, and he thought, what was the force that made that apple fall down? Why didn't it fall to the side, or why didn't it fall up? So Newton did many experiments to learn how gravity works. He discovered 3 laws of moving objects that are still used today. And we call those the laws of motion. Hi, I'm making a video. Want to say hi?
Hello, students. And John Christie.
Okay, I'm not sure what he said there. Let's see. So just a little info about Isaac Newton that I thought was interesting. And if you wanted to pause this and read the rest of this page, you could do that. All right, so forces are all around us. Forces make things go faster and slower. They make things stop. They make things start. Forces get things moving. All right, so today we learned a little bit about 2 powerful forces, the forces of friction, that's that rubbing, everything has little particles and bumps, and we also learned about the force of gravity, and that is, when we talk, about gravity, we mean the Earth's gravity, that everything is being pulled toward the center of the Earth. It's kind of like, I like to think about it as the core of the Earth, the inner core, and it is made of metal, we learned about that. It's sort of like a giant magnet. It's kind of pulling everything down to the center of the Earth. So on these last couple of slides, these are just some optional activities that you could do about friction. So if you wanted to pause the video here, you could read about these little experiments that you could do at home that have to do with friction, kind of getting some different objects here, and then seeing if you can put some toy cars and see how fast or slowly they go on different materials, because some of these different materials have different amounts of friction. All right, and then there's just a little bit more, and here's a picture of how you could do your experiment with friction. All right, so to recap, friction is the force of objects rubbing together. Friction makes moving objects slow down. Gravity is the force that every object has for every other object. And like we said, when we talk about gravity, we're usually talking about Earth's gravity that pulls everything down toward the center of the Earth. So friction and gravity are 2 powerful forces. And that is all I have for you today. So go ahead and do some experiments. Take a look around your house. See if you have some objects that you could test for friction. You could also test some things for gravity. You could stand on a chair, drop some objects onto the floor, and see if they all fall down. I am making a hypothesis, what I think the answer might be. I'm making a hypothesis that those objects are all going to fall down. Try it out. Bye.